Hello. Alright, we continue today's lesson. Alright, still on graphs of motion. Okay, now previously we saw the concept of a distance against time graph. So this is what we got, a simple graph that we plotted based on the equation and range given for your time. Alright, so it's actually in a straight line. And here when we calculate the gradient, we found that the gradient is actually negative. Alright, meaning the speed here is negative. That means what they're trying to say is actually moving from one point, that's my distance, okay, to a point that this is where the object stops. Because why? There's no more speed here, right? Distance is 0, means it has actually reached its destination. So the object actually stops moving. So negative speed. Alright. So this is one example. Now, graphs of motion can actually vary in shapes. Alright. So it's got many shapes to it depending on what the equation is all about and what kind of object is actually moving. Alright, so I just picked up two examples. Alright, they may look like this. There may be different parts of the graph. Like previously we actually saw just one straight line like this. Okay, now maybe the graph can actually look like this. This is distance against time. So I've actually got three parts of movement here. This one is from O to A. Okay, this is where the object or the particle actually starts to move. So it moves up to A. Okay, here if you notice, if you're going to actually look at it as a straight line, it's a straight line. So we can actually say that here the gradient is being positive. The gradient is actually positive when you actually calculate, and it looks uniform. So if you notice, this is a 2 by 2, so meaning we can actually say that the speed is actually uniformly increasing from O to A. Alright, so O to A, gradient positive, speed is positive. Alright, and it's actually uniformly increasing. Alright, okay, now object is at A. From A to B, we notice the graph is actually flat. It's also a straight line, but it's flat. Okay, so what we can actually interpret from here, just now here we said the gradient is positive. So here if you notice, if the line is actually horizontally drawn, here means gradient is actually 0, meaning there's no speed. If there's no speed, means the object is actually not moving. The object here is stationary. So if you notice, the distance from A to B remains the same. But here you see it starts from 0, is actually picking up. Alright, to a certain value here, which is 20. But from A to B, the distance remains the same. So what we can actually interpret from here is, at this point, the straight line here means the object is not moving. Okay, so that's the point where it's actually stationary. Okay, and then from B to C, what's happening again? Okay, the distance is actually, notice, the distance is actually getting higher. The values are actually getting higher, meaning the object is actually moving further and further away. Okay, until the peak. This is the peak. This is where the object. So this is about 50. So this is where the object reaches from its original point O. So that means from here up to here, the object has actually moved, or the particle has actually moved 50 km. So distance is in km. So that's the distance covered. So here if you notice, gradient, straight line is positive, means the speed is actually increasing, okay, from B to C. Alright, until it reaches point C. So here I repeat, it's moving from O to A with a uniform speed. Here it stops, so it's stationary, and from B to C is actually moving again until it reaches point C. Alright, so for this moving particle starts from O and it ends at C. Alright, okay, if you look at this graph, this is also another graph that's actually distance against time. So what you can actually see from here is Okay, let's say the particle starts here. Normally it starts from the origin. So from O to A, it's the same concept as this. Okay, it's a straight line, means gradient positive, speed is also positive, means it's actually moving forward. Okay, from A to B, if you notice the distance is the same, means here particle does not move, it stops, right? Okay, the particle stops, it doesn't move from A to B. So there's no speed. Speed is actually 0. And then from B to C, if you notice, it's actually moving. You can actually see that it's moving back from where it starts. So meaning this particle is actually starting to move. It starts to move from here. It goes to A. It rests for a while. It stops for a while. And then it actually comes back to from where it starts. Okay. So here, the gradient is negative. Speed is also negative, means the particle is actually returning to where it started from. Alright? Okay. So these are two graphs. Another two types of graph that you actually see for distance against time. Alright? Okay. Now another thing that you can actually conclude from a graph is, or what you can do, what you can actually observe from the graph is the speed, like what we have seen before. Speed is actually distance over time. Okay, there is one more concept of speed that is also introduced, okay, under the motion. Okay, this is known as average speed. Speed will normally be, example, speed. You're talking about speed. Let's say we are only calculating speed from O to A. Alright, but when you're talking about average speed will be, you know what's average? Average is actually the mean. Means a particle, when it actually moves, it has got different speeds along the way. So what happens now is it actually, from O to A, the speed is different. From B to C, the speed is different. From O to A, speed is different. A to B, it is not moving. B to C, this speed is also different from this. If you notice, the gradient is different, means speed is different. So you're talking about average, means actually averaging out this part and this part, this speed and this speed. So when you're talking about average speed, means here the formula is a little bit different, where it says average speed is actually total distance traveled over total time taken, meaning the speed is from here right up to this point. Okay, this whole thing, this is called the concept of average speed. Speed is only for that one portion, but average means the entire graph from where the particle starts to move until when it stops. Okay, so if it starts here and it stops here, we calculate the total distance traveled. So in this case, the total distance is up to here over the total time taken, which is here, 6. Okay, so that means my average speed will be from here, total distance is 50 over total time taken, which is 6. Okay, so the average speed becomes 50 over 6. So that's the difference here. Okay, so average speed is total distance traveled over total time taken. Okay, so now here we've got a concept of positive gradient. Positive gradient means here the speed is actually increasing. Okay, zero gradient means there's no speed. No speed. No speed means flat, no gradient. That means there the object actually rests, is not moving. And negative gradient means we can actually say that the speed is decreasing. Okay, the speed is decreasing until it actually stops or it goes back to its original position. Alright, so these are some of the interpretations that we actually need to know. So when we actually cover different types of graph after this, we'll actually look into more terms, okay, on what we can actually use the graph to interpret. Thank you.